Okay, here's the final section for Chapter 9. This section is going to be called Systems of Quadratic Equations. So go ahead and label your notes this right here, 9.5, Systems of Quadratic Equations. So this is very similar to what we learned back in Chapter 4. I believe it was Chapter 4, where we learned about system of linear equations, where we would have two equations and we would want to know where they intersect, right? So let's do a recap. Or a reminder. The system is a system of equations is a group of equations within the same context. Okay, so for example, I might have two different equations that represent lemonade sales. Let's say that I was selling lemonade, and let's say that my neighbor was selling lemonade. You could have two different equations based on my sales versus my neighbor's sales, but you would also know that you could find a spot where the two meet, right? And so the answer or the solution is the point or points where the equations intersect. Okay? Let me show you just an example here. So if we're looking at quadratic equations, let me draw an example of two quadratic equations. And I'll just kind of pick random structures for them. So first off, let's make one that looks like this, right? So there's one equation. And then let's say we have one that looks something like this. So here we have a system of two quadratic equations, right? And the point where they intersect, those would be the two answers, right? Those would be the two solutions. So here's a system, what it would look like graphed, and where my answers would come from, are those 2 points where they cross, okay? Let's do an example without the graph. So let's say this is example A, and let's go ahead and label this up here. This is going to be using the substitution method. Substitution. Okay? So substitution method, we've got example A. We've got y equals x squared plus x minus 1. Y equals negative 2x plus 3. Okay, so something to note is that if I'm going to draw kind of an image of what this should look like, I know that this is going to look something like this, right? I'm going to have some kind of quadratic, okay? And then this piece is going to look something like a linear equation. In fact, it's going to be one that has a negative slope, so it's going to be going down like this. So it might look something like this, right? So here we see what they should look like on the graph. So we should end up getting two different points, possibly. They could miss each other as well, so there could be no answer, or they could meet at the vertex. If they meet at the vertex, then they'll have one solution. So let's use substitution to see what the answers might be. So first off, for using substitution, we're going to substitute two things that are equal to each other. So notice that y is equal to y. So these two things are equal to each other. So if these two things are equal to each other, then guess what? These two things need to be equal to each other. Because by the transitive property, y equals this, but y also equals this. And if that's true, then this must also equal this. So I can cut the middleman out, and I can write x squared plus x minus 1 is equal to negative 2x plus 3. Now I've cut the middleman out here. I can just solve for x. Notice that the y is now missing, which means I don't have to worry about the y, and I have one variable, so I'm just going to solve for that one variable. So I'm going to, oops, not 3. Add 2x to both sides, and it's going to help get rid of this right here. So it's going to give me x squared plus 3x minus 1 equals 3. And then my last step is going to be to subtract 3 from both sides. And that's going to give me something that looks like this. Okay, so now I get to kind of pick whatever method I want to solve this. Remember in the last section, we went over the 5 different methods that you can use to solve this. So I can do factoring, which I'm going to check that real quick. Is this an easy thing to factor? Can I get, is this a 1? Yep, it is. If there's nothing written there, then it's a 1. And is it easy to tell what adds to make 3 and multiplies to make negative 4? Well, for me, I know that there's only 2 possibilities for what makes 4. That's either 1 times 4 or 2 times 2. And in this case, if I take 1 times 4, but I make the 1 a negative, so I get a negative answer here. So negative 1 times 4 makes negative 4. And then when I add the 2, negative 1 plus positive 4 will create a positive 3. So that's actually a pretty easy one to factor, which gives me this. And then now I just need to solve for x. So I'm going to use the zero product property, where it says that if I have 2 things multiplied to make 0, one of them has to be equal to 0. So either x minus 1 is equal to 0, or x plus 4 equals 0. And then I just solve for x on both cases, which gives me 1 or negative 4. Those are my 2 possible answers. Now for this, I'm actually going to have to plug both of these in to find the exact points, because look, I need 2 different points here. Let's say that this actually represents the negative 4 answer, and then this represents the positive 1 answer. Right? So maybe our actual graph looks something like this, right? Something like that, which it's not going to look like that. It's actually going to be pretty different from that. But that's just a guess, right? And so I need to find the 2 y values as well. So first, let's plug in this one. So y equals, and now I get to pick either one of these, whichever one I think is easiest. And I'm going to tell you right now, the linear equation is always going to be the easier one. So I'm going to plug in 1 here, negative 2 times 1 plus 3. Y equals negative 2 plus 3. Y equals 1. Okay, so my first answer, I'm going to go ahead and put it right here, is going to be at 1, 1. Okay, that's my first answer. Now I'm going to plug in the second point. Y equals, and once again, I'm going to use that linear equation because that's a lot easier to calculate. That gives me 8 plus 3. Y equals 11. So now my answer here is negative 4, 11. So my 2 solutions are, I'll just write them right here, 1, 1 and negative 4, 11. Those are my 2 solutions. Okay, and that's how we use the substitution method, or at least that's one way to use the substitution method, where we just cut out the middleman, solve for x. We can use whatever method we want to find x. Once you do that, you need to find both of the y values to find the 2 different points. Okay, so go ahead and do page 484, or sorry, 488, numbers 1 through 3 all. So go ahead and start on that, and then we'll find the answers in the next video.